Hello everybody. Today I can expand logarithms using the product, quotient, and power rule. So I'm going to show you where these rules come from. I'm going to show you how to use them, and it's going to be just fantastic. So we know that logarithms are based on exponents. We know that logarithms are the inverse of exponents. So let's use the rules of exponents to help us come up with the rules of logs. So let's start with multiplication. When I'm multiplying exponents, what do I do with my powers? Well, I add them. Multiplication becomes addition, and now we get x to the fifth. So the same holds true for logs. My product rule, when I'm multiplying, the multiplication becomes addition. So my product rule, log of A times B equals log A plus log B. When I expand into multiple logs, multiplication becomes addition. X to the fifth divided by x to the third. When I'm dividing exponents, I subtract. Quotient rule. Log of A divided by B is log A minus log B. When I'm dividing, division becomes subtraction when I expand it into multiple logs. And finally, when I'm raising a power to a power, I multiply. It becomes x to the 5 times 2, which is x to the 10th. So my power rule, when I'm raising a log to a power, it ends up being multiplied. Essentially, what happens is the power comes in front, but technically it becomes multiplication. When I'm expanding, when I'm applying my rules, always do product and quotient rule first, and then do power rule last. All right, we're going to do our product and our quotient rule first. We're going to do our power rule last. One other thing I want to review before we go on to this lesson that we're going to need from a previous lesson is radicals. Radicals are fractional exponents. We did that earlier in the unit. So whenever you see a radical, you want to rewrite it as a fractional exponent. Let's get a better color. So for example, if I have the cubed root of x squared, radicals are fractional exponents. It's the power over the root. So in this case, it would be 2 over 3. So we're definitely going to need that in this lesson. If I had radical x to the 5th, well, the imaginary root is a 2. The power over the root, the power is 5. The root is 2. Why don't you try and rewrite this one right now on your own? Radicals are fractional exponents. It's the power over the root. The power is 3. The root is 4. And that's it. All right, so we are going to need to utilize that. Actually, did I? Yeah, I did put that in there. So let's start real simple. Now, you might want to take a picture of this, take a screenshot of this, because you definitely need to know these rules. We're going to be using these rules. So definitely have these rules to refer to as you are going through these examples. I always want to do my product in quotient rule first, and then my power rule last. So I'm looking for multiplication or division. Do I see multiplication or division? Yes, I see multiplication right there. So multiplication becomes addition. So it becomes log x, multiplication becomes addition, log y. Now when I break it apart, log goes in front of everything. Okay, so when I'm writing the multiple logs, make sure you write log in front of each term. And that's it. Number 2, I see division. Well, division becomes subtraction. So this becomes log 7. Division becomes minus log x. And that's it. Number 3, I don't see multiplication. I don't see division, but I see a power. So the power rule tells me to bring the power in front to become multiplication. So the power comes in front and everything else stays. Now if there's a log base, then you just carry the base along. The base will not change. The base doesn't really change anything. Just if there's an exponent, the power comes in front, and that's it. Now we're going to start combining stuff. This question is where it gets real. First thing I'm doing is my product in quotient rules. Look for multiplication and division. I see multiplication and I see division. Because the log is base 9, when I write my multiple logs, they're all just going to have a base of 9. So log base 9 of x to the 4th. Multiplication becomes addition. Log base 9 of y squared. Division becomes subtraction. Log base 9 of z. That's my product rule. The multiplication became addition, and the quotient rule, division, became subtraction. Now I'm going to apply my power rule. My power, or my exponent, comes in front. There is no exponent in the last term, so I'm not going to do anything with that. So it becomes 4 log base 9x plus 2 log base 9y minus log base 9c. And that's it. ln, same thing as log. I look for multiplication or division. I see multiplication. I know multiplication becomes addition. So I want you to try and do the first step right now on your own. Make that multiplication into addition. I'll give you about 10 seconds to do that. Okay. Ln x cubed, multiplication becomes plus ln, or ln of y squared. I say ln. Ln, it's all good. Now apply your power rule. Look at what we did in the previous example. The power just went in front of the log that it was attached to. So I want you to take about 10 seconds and try and apply the power rule here. Okay. Power just comes in front. 3 ln x plus 2 ln y. That's your answer. I want you to try number 6 on your own right now. So please pause, try number 6 on your own, and then unpause. Okay, now that you tried number 6 on your own, I start with my product and quotient rules. I'm looking for multiplication and division. I see them. My log base is x, so when I make my logs, I'm just going to make sure they all have a base of x. Multiplication becomes addition, so I write log base x of b. Division becomes subtraction, log base x c to the 4th. Multiplication becomes addition, division becomes subtraction, and whatever the log base is just kind of comes with it. Now I'm going to apply my power rule. My exponent comes in front. There is no exponent on the b, so I'm not going to do anything there. And I get 2 log base xa plus log base xb minus 4 log base xc. And that's my answer. There's just one more twist that I want to deal with. So let's skip ahead to number 8. I see a radical. Well, we know that radicals are fractional exponents, so I want to start by rewriting the radical as a fractional exponent. So I'm not going to do anything with log rules yet. I want to just rewrite the radical as a fractional exponent. I know that radicals are fractional exponents. It's the power over the root. The regular radical has a power of 1 and a root of 2. So if you ever see a radical, you need to rewrite it as a fractional exponent. Now I do the same thing that we just did. So I'm going to give you about 30 seconds right now to see if you can complete this one from here on your own. I see division. So division becomes subtraction. Now I apply my power rule last. And I get 1/2 ln x minus 3 ln y. And that's my answer. So if you see a radical, your first step is to rewrite it as a fractional exponent. And once you have that, you just do everything the same way that you did. So that's it for me. I think at this point you can do everything else on your own. Again, I can expand logarithms using product, quotient, and power rule. Make sure you do your product and quotient rule first and your power rule last when you're expanding logs. Make sure you know your rules. Multiplication becomes addition. Division becomes subtraction, just like the exponent rules. And your power rule, when you have an exponent, the power comes in front, because when you raise a power to a power, you're multiplying. That's essentially what's happening there. Your classwork/homework is to finish this worksheet, and I hope everybody has a great day.